In today's lesson, we're talking about equivalent ratios. Equivalent ratios are ratios that mean the same thing. One of the most common applications for equivalent ratios is cooking or baking. When we want to make more food, we have to make sure that our ingredients are in proportion to one another to give the desired outcome. Suppose a cookie recipe needs to have 2 eggs and a stick of butter. Okay, so it needs 2 eggs and a stick of butter. Which of the combinations below are equivalent to the one above? Is this one equivalent to the one above?
Yes.
No. How do we know that?
Because there's only 7 eggs.
What's that?
Because there's only 7 eggs.
No, it's this one. Sorry, just so we're clear. It's this one right here. There's 4 potential, well, actually, yeah, one here and one, actually, wait a sec. There's 3. Well, this one, this one, this one. So this one is not, because you double the butter, right? You double the butter, but you don't double the eggs. This one here, you double the butter and you double the eggs. So this one is okay. This one here, you multiply the butter by 4. But if you multiply 2 eggs by 4, it means that you should have 8 eggs. And here there's only 6 eggs. So it's not this one, it's not this one, but this one works. So no, no, and yes. Okay? We can find equivalent ratios the same way that we find equivalent fractions. You multiply or divide both numbers, or so I know ratios sometimes have 3 numbers, so you multiply or divide all the numbers by the same number, and you'll find an equivalent ratio. A ratio is in simplest terms when the numbers do not have any common factors. So, example, the ratio of dogs to cats is 9 to 12. So give me an equivalent ratio to that. What's that? Well, you're answering the second part, because the second part asks us to put it in lowest terms, and that would be 3 to 4. I don't want that as an answer here. Give me an equivalent ratio. 18 to 24, and you get that how?
By doubling each.
By doubling each number. Sure, 9 doubled is 18, and 12 doubled is 24. So we double 9 and we double 12, and we get 18 and 24. And then Mia jumped the gun and told us that the second one was 3 to 4, and we get that by dividing both of these numbers by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So that is the ratio in its lowest terms.
Is it always divided by 3?
No. It totally depends. If I gave you a question like 21 to 35, we would have to divide these both by 7. You have to look at the numbers and identify, using your vast and extensive mathematical knowledge bank, what's the biggest number that divides into these. It's like reducing fractions into lowest terms, okay? You have to figure out what you divide the numbers by.
I didn't get the 2 words.
Now, next question, here we go. Write 3 ratios equivalent to 4 to 7. Use a table. We don't have to use a table. But 4 to 7, okay? So, okay, give me an equivalent ratio to 4 to 7. What's that? 8 to 14, and we get that by multiplying them both by 2, okay? And I might just write that down over here just so I got it. Okay, multiply them both by 2. I got 8 to 14. Cool. Give me another one. Jacob.
12 to 21.
And we get that by multiplying the numbers by
3.
Very good. And one more.
Oh.
Parker.
16 to 28.
And you get that by multiplying the original numbers by what? 4. Good. Okay? So 16 to 28.
Oh, sorry.
There you go. There are 3 equivalent ratios to 4 to 7. And again, we get equivalent ratios by multiplying the numbers by the same number, okay?
We can do it in whatever way we want. We can times it by 50 if we want.
Yep. Next question. Write 3 ratios equivalent to 8 to 2. So Bentley, you came up with 50, so let's go ahead with that. Multiply these both by 50. What do we get?
50 or 100.
What's 2 times 50?
100.
Good. What's 8 times 50? Parker? 400. Good, there's 1. All right, so we did that by multiplying by 50. Awesome. Now let's multiply by something else.
100.
What's that?
Okay, I just said 100.
Fine, do 100, okay? So, the first one's going to be what then? 800. Second one's going to be what?
200.
Good. Okay. Give me another number. Parker.
150.
What's that?
150.
Okay.
You do an odd number.
So what's 8 times 150? What's that? Good. And what's 2 times 150? Good. All right. You don't have to pick numbers that big.
That's some very mathematical word or
All right. Now we're going to do one more problem, and then I'm going to get you your practice questions. So, the orange toad bakes 36 muffins, 60 cookies, and 18 mini loaves of banana bread. Write a ratio that compares each type of baked good to one another. What do you got for me?
Wait, can we just add the 2 together?
No. Because it tells us about 3 things. 36 muffins, 60 cookies, and 18 mini loaves. So why don't we write 36 to 60 to 18 like that? And order matters, so we put the numbers in the order in which they appear in the question, right? Muffins come first, so 36 muffins comes first.
Can you just add like 30 and 60 together and then say
No.
that as like
No, we're just gonna write them out like that. 36 to 60 to 18. Give me 2 equivalent ratios to this.
2?
Parker.
To the first one?
Yeah.
What you were talking about?
Times 35.
So what do you want? What do you want to do?
Divide by
Sorry.
Divide by 2.
Divide by 2. What is the new ratio? You divide by 2. You cut something in half. Half of 36 is
18.
good. Half of 60 is 30. Half of 18 is good. Okay. Now give me another one.
Divide by 4.
That won't work.
Oh yeah.
Divide by 6.
Divide by 6. So Janae, divide those original numbers by 6. And what do we get?
6.
Yes?
10.
Yes?
And 3.
Beautiful. There you go. So we got the first one by dividing by 2. And we got the second one by dividing by 6. So you can multiply or divide. Not all ratios can be divided. And no ratio can be divided by all numbers. Like I heard 4. Well, you can't divide. You can divide 36 and 60 by 4, but you can't divide 18 by 4. So you have to pick a number that divides into each of the numbers evenly. So that is going to be the challenge.
You do 18.